Hi everyone, welcome back. We're going to continue on now and finish off the ARM controls. Basically what we need to do is add in an IK handle similar to the leg. We're going to connect up the IK to the control just here. We're going to connect the IK up to the elbow control with a pole vector, and then what we're going to do is add in an expression which allows us to control the rotation of this new joint with the rotation of this wrist area. So let's start off by adding in our IK. Over in the rigging tab, you can either grab the IK handle tool just here, or you can go to skeleton, create IK handle, just go into the options for that. And what we want is a rotate plane solver, which is what we used for the main leg IK. So I'm going to connect the rotate plane solver from the shoulder down to the new joint in the forearm. The reason that we're not adding it to the wrist is that if we add it to the wrist, it will treat the forearm joint a bit like an elbow as well, and it'll cause the arm to bend at this position. So what we need to do basically is position the IK just here, and you can see basically that that's going to keep the forearm rigid when we move the character's arm around. But what we need to do is basically make the IK think that it's actually at the wrist location. And the way that we do that is by changing the pivot point on the effector that's connected to the IK handle. So if you go into your outliner and you look for your left collar joint just here, so currently the left collar joint is this one, and it's not connected to the rest of the skeleton yet, so it has its own hierarchy just here, left collar joint. So if I hit shift and expand that out, what I'm looking for is this effector just here. Okay, so the effector itself will be connected back up just underneath where it says joint 1. Okay, so this is joint 1. We need to rename that, but that's where the effector is. Okay, so what I'm going to do is select that effector. Okay, by default it's hidden. It's sort of, it's just a little object node that's hidden. I'm going to select that, and I'm going to move the pivot point for that effector to the wrist. So we can turn on snap to point and then hold down the D key or hit insert on the keyboard. Or you can hit edit pivot over here. So I'm just going to drag this across to the wrist like that. And then if I turn those options off again, and I go back down and I select my IK handle just here, I can now move the arm around, and it's basically treating it as though the IK is actually at the wrist, even though technically we only added it to the forearm just there. So I'm going to rename this IK handle so I know what it is. This is going to be left wrist IK. Okay. Technically speaking, you could change the name of this effector as well, and you could call that left wrist EFF for effector, so you know which one it is. And the joint here that we attached it to, this one just here, I'm going to rename this. So I'm going to call that left forearm JNT, like that. Okay. It can actually help to not have that named prior to adding in the IK, because it makes it stand out in the list if it's just if it just says joint. So you'll want to obviously repeat that process on the right arm as well. Okay, the exact same process. Okay, so the next thing I want to do is I want to add in the connections between the arm control and the IK for the arm. So at the moment I've got the control object, and basically at the moment that does nothing because it's not connected. So what we're going to do is connect this in two separate ways. The first way that we're going to connect it is using a point constraint onto the IK handle itself. So that way, as the IK handle moves, as the control object moves, the IK handle will move with it. Then what we're going to do is connect the rotation of the hand or wrist joint onto this handle as well. So what we'll do is we'll select the control handle for the wrist. We'll shift select the IK handle just there. We'll come up to constrain and we'll use a point constraint. Okay. We want maintain offset on and we want constrain to all axes. So what you can do is just hit edit reset settings, okay, and then just turn maintain offset on like that and hit add. So now what we'll get if we just move the handle is the IK will go with it like that. So now what we need to do is connect the rotation of the wrist joint just here onto the same handle. So I'm going to select the handle, shift select the wrist joint, and then come up to constrain. And this time I'm going to use an orient constraint. So I'll go into the options again. And once again, we want to constrain all axes and we want to maintain the offset. Now what this is doing, maintain offset, what this does is whatever angle this joint is at the moment, it will remain in that position or rotation when we connect it to the handle. If the rotation of this joint is slightly different in value to the rotation of the handle, when we connect it with maintain offset switched off, the joint would rotate to match the handle's rotation. Okay. Now we've got everything zeroed out over here more or less to a certain extent as far as rotation is concerned, so we shouldn't see any movement anyway, but it's probably best to have maintain offset turned on. So I'm going to hit the add button there, and you can see it's basically locking the values out like that. So now what we get is movement using the move tool. That's going to move the IK handle around like that. So if we move close to the body, you can see the elbow bending there. Okay, but if we rotate the handle as well, we can now rotate the position of the hand like that. Okay, so once again, you'll need to repeat that for the right arm. Let's now connect up the elbow control just here. And what we want to do is pole vector constrain that onto the IK. So I'm going to select the elbow control, shift select the IK, and I'm going to come up to constrain pole vector. Okay, you'll see the connection line add in like that. And now if you grab the elbow control, you can now move that around and twist the arm. Okay, so for example, if I place the character's sort of arm down like this, I can grab the elbow control and I can adjust the position of the elbow to suit the pose that I want. Okay. The last thing we need to do is set up an expression to control the rotation of this joint when we rotate this handle. And that's going to give us a slight forearm twist. So we're going to go up to the Windows menu, across to Animation Editors, and down to Expression Editor. And that's going to open up a panel like this. And what we're going to do is create an expression which is going to connect the forearm joint to the rotation of our control handle. So we're first going to add in an expression name. And I'm going to call this left forearm twist. And then down in the expression panel, what we're going to do is type in a short single line expression. Now it's really important that you get all your spelling correct inside this expression. If you don't, it's not going to work properly. We also need to make sure that we're using all of the object names that we typed in for our specific joints and control objects and so on. So in this case, I'm going to type in left forearm JNT, joint. So it's exactly the same as the joint's name in the outliner list. Okay, just up here. I'm then going to type in the rotation channel after that. Also keep in mind you need to make sure you're getting all your capital letters correct. If you've spelt things with capitals, they have to be capitals in this. So then we put in a full stop and we type in what we want to control, and in this case it's going to be the rotate X value. So we type rotate capital X all in one word. Then we put a space equals space, and then we need to type in the name of the control object that we're going to use. So in this case it's the left wrist control. So we need to make sure that we're spelling that correctly as well. So you can always check in your outliner list to make sure that you're getting it correct. And I can see my left wrist control curve down here in the list. So we're going to type that name in. So L underscore wrist underscore control. And we're going to use the pretty much the same rotation value to link to between the joint and the controller. So we put in full stop rotate X. Now what we're going to do here, what this is essentially doing is it's saying the forearm rotation X equals the wrist control rotation X. So that's going to give you a one-to-one rotation. If you rotate the control like 10 degrees, it'll rotate the joint 10 degrees. What we want to do is have a fall off on the twisting. So we don't want the joint to rotate 100% of the control. We want it to be half. So we put in a space, then divide by, which is a forward slash, then space, and then the number we're dividing it by, which in this case is 2. So the rotation on the joint is going to be half of our full rotation of the control. Always put a semicolon at the end of your line as well, at the end of your expression. Now what we can do is actually, you could copy and paste that and then repeat the same process for the right arm, paste that in, and then just change the lefts to rights, the L's to R's. Then all you do is click the create button, and that will add in. You'll see at the bottom you'll get the result left forearm twist expression, and you can turn the panel off. So now if we go over to our control handle, we select that, grab the rotate tool. If we rotate it on the X value, we should then see the forearm joint twisting half the value that we rotate the control object, and you can see that working there.